Implicit differentiation. We differentiate the left-hand side, we differentiate the right-hand side. I start with the outer function, so cosine prime is negative sine times the inner function prime. The inner function is a product. This is the first function, this is the second function. So the first function prime is 1 times y plus the first function times the second function prime, which we do not have. Is this okay? Yes? Perfect. We differentiate cosine, we get negative sine. And now I have to differentiate the inner function, which is first function prime is 1 times the second plus the first function times the second function prime equals 1 prime is 0. And then sine prime is cosine y times dy over dx. Is this okay? Is this okay? We are solving for this, but it's not ready yet because I have to distribute this to these two terms first. So negative y sine xy minus x sine xy dy over dx equals cosine y dy over dx. Is this okay so far? Yes? Any questions? Now we see two terms with a variable. I'm going to move this term to the other side and factor out dy over dx. This term goes here when I factor out dy over dx. Agreed? Okay. So the left-hand side is negative y sine xy, and the right-hand side is x sine xy plus cosine y dy over dx. And finally, dy over dx is this over this. Is this okay? Yes, everyone? So negative y sine xy over x sine xy plus cosine y. Don't try to do anything because there is no way we can simplify it. Any questions? Any questions? Okay, now can I go back to these problems or you have anything else right away? Any questions on this? Yes.
When you first calculated cosine, way in the beginning, cosine x, y.
Yes, so this is a function, the outer function, this is the inner function.
Right.
So when I differentiate cosine, I get negative sine of the same thing. But then times, if this were x, I would have stopped. But this is a product of two functions. This is one function and this is the other. So then I have to multiply by the inner function prime, but because it's a product, the first function prime is 1 times the second one plus the first function times the second one prime. And then on this side, I have 1 prime, which is 0, and then sine y, outer function, inner function. When I differentiate sine, I get cosine. But I have to multiply by the inner function prime, which is dy over dx.
I got that. Right? Just the xy is
Okay.
changed because the xy is
Yes. 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 If we had only cosine x, I would have been done. Are the rest of the steps clear? Everyone? Okay. So we wanted to look at 28. on 248, 49. 28, 249. Okay. So here's the kite. And it's 100 feet above ground. Moves horizontally this way at a speed of 8 feet per second. So what does 8 feet per second represent?
dx.
Over dt. Perfect. At what rate is the angle between the string, theta? At what rate is the angle between the string and the horizontal decreasing? So what am I asked to determine?
Find d tan dt.
When, so I'm going to call this W. When W equals 200 feet. So a kite 100 feet above the ground moves horizontally at a speed of 8 feet per second. At what rate is the angle between the string and the horizontal decreasing when 200 feet of string has been let out?
W equals 200.
Yes. When 200 feet of string. Okay. So obviously I have this. I need to involve this, and I need to involve this. I'm definitely thinking of a trig function. A trig function that uses the opposite and the hypotenuse.
Sine.
Exactly. So I'm going to say that sine theta equals 100, which is fixed. This does not come after when. This is given to us. That's the height of the kite forever, no matter what I do. So that's why this is fixed. So it's 100 divided by W. So far, so good? Okay. Now, I do not know anything about W other than that W is a function of time. So if I solve this equation for W, because that's actually, I want theta. So regardless of what I do, I can write sine theta equals 100 times W to -1. And here I have two functions. I have a function of theta, I have theta, which is a function of time, and I have W, which is a function of time. I do not know the rate of change of W, but I do know the rate of change of X. So somehow I have to involve this X because that's what I'm given. So this dx over dt has to help us determine dy over dt, dw over dt. So when I differentiate both sides, let's see what we have. Let's see what we get. Just for 1 second, and then we'll come back. So when I differentiate the left-hand side, I have cosine theta times d theta over dt. The right-hand side is -100 times w to -2 times dw over dt. Or cosine theta d theta over dt equals -100 over w squared d theta, dw over dt. I will divide by cosine theta, and I got the expression I need, but I don't have all the pieces though. So d theta over dt equals -100 w squared cosine theta times dw over dt. So this has to be determined when W equals 200 feet. Now, I don't have a problem determining cosine theta because I know that this is 200. So I'm coming back here, right? So this is 200, this is 100. Then I know exactly what theta is, right? So theta, sine theta is 1/2. What angle is theta if sine is 1/2? Careful. It's the tiny one.
30.
30, yes. So this is cosine of pi over 6. So there's no problem there. W I have is 200. So all these are given to us, but I'm having one problem here, finding dW over dt. So I have to come up with something that involves dx over dt. So now I'm going to connect w squared equals 100 squared plus x squared, because that's how I get dw over dt. So I write the Pythagorean theorem as w squared equals x squared plus 100 squared. And from here, when I differentiate implicitly, I will be able to get an expression for this and get it done. So I differentiate the left-hand side and differentiate the right-hand side. So the left-hand side is 2w dw over dt, and the right-hand side is 2x dx over dt. I will simplify the 2's, and I got what I wanted. dw over dt equals x over w dx over dt. And that's exactly the piece that I was missing. And now I have all the pieces. I can put them together. You can say, but what about x? Well, there's no problem. I can find x easily, right? If I know that theta is 30 degrees, this is cosine, right? Or I can just use the Pythagorean theorem and determine x when w is 200. We're going to do that. Any questions so far? Is this clear? Okay, so I have dx over dt is given to us. I have w, which is 200. I have to determine x and put it in here. So replace dw over dt with this. But again, I'm missing a little piece, which is x, which is here. So x will be the square root of 200 squared minus 100 squared. The hypotenuse squared minus the other leg squared. You don't have to calculate anything. We can just put them in and calculate everything at once. So finally, d theta over dt, when x is 200 feet, is negative 100 over 200 squared times cosine. So this is cosine of pi over 6, which is the square root of 3 over 2. I'm sorry? Yeah. 200 squared.
I'm talking about the x equals 200. One you just read. Down. Down a little bit. Next page on. Oh, fingers on it. There it is.
Ah,
There you go.
thank you, sorry. Sorry, it is w, sorry. So times dw over dt, so x is at the top, the square root of 200 squared minus 100 squared. W is at the bottom, which is 200. And dx over dt, what was it? That's on 8. So we replaced everything. I'm going to try and simplify a little bit so I don't put so many things in. So I'm going to cross these two zeros. I'm going to simplify a 2 in here. So let's see what is left. Negative 4. 200 squared minus 100 squared. And also multiply by 2, because I have to flip this. So it's 8. Over 200 squared times the square root of 3. Is this okay? So I crossed out 100 with 100 when I crossed out a 2 with a 2. So I got a 4. But I have to flip this fraction, so 4 times 2. 200 squared and the square root of 3. Is that okay? So let's look at the graphing calculator. So I have 8 and then the square root, and I always put parentheses 200 squared minus 100 squared, close the parenthesis, and then outside I have to divide in parentheses 200 squared and times the square root of 3.
Didn't the 8 become a 4?
Yes, but I also have to flip the denominator.
Oh,
That's square root of 3 over 2. Because we know that
right.
the angle, since sine is 1 over 2, is pi over 6. So then, so then this is cosine of pi over 6, which is the square root of 3 over 2. So I had a 4, but then when I flip this, it will be 4 times 2, which is 8. Is that okay? So this is what I got. And now click enter. So what is this measurement unit? Negative 0.02.
Is that radian per second?
Very good. It's theta.
I got that right.
Well done.
I thought I was way off.
Well done.
I did it differently.
It's fine. Whatever works. Any questions? Any questions? Okay, the next problem you selected was 34 on 255. I sound like a friend of mine has a son or a daughter, I think. I never met none of the kids, but he always tells me that his kids say 2 plus 2 is 22. Okay, 255, 34. Yes. The radius of a circular disc is given 24 centimeters with a maximum error in measurement of 0.2. What does this represent? What does 0.2 represent? Excellent. Use differentials to estimate the maximum area in the calculated area of the disk. So, what am I asked to find? The error in the area.
DA.
So I'm asked to find dA, right? So first I have to find the area. So this is the question. How much is the area of a disk?
I swear.
That's it. So now let's find the A. Now let's write it first and then we'll plug it in.
Is that
2 pi r
times I r squared?
Thank you. The differential of A, just remember, it's a big difference between the function, the derivative of the function, or the differential of the function. The differential is f prime of x dx. So dA is A prime dr. because a depends only on r. So this is like a function of x. So the differential of a is f prime of a. It's a prime times dr. So now I can calculate it as 2 pi times 24 times 0.2. So I can calculate that. So I got 30.159 measurement unit.
Centimeter squared.
Perfect. Part B. What is the relative error and the percentage error? What are we asked to find in the relative for the relative error?
Over
With respect to the original, that's what it is. That's a relative error. If you want to find out, for example, how much your salary percentage-wise increased based to the with reference to the base function that you started with, you determine the difference, the height, and you divide by the original value, original salary. And you can say my salary increased by 5%. Okay? So dA over A, so this is 30.159 divided by pi r squared, pi times 24 squared. So I divide the previous answer by pi and by 24 squared. I got 0.016666, 0.0167. No measurement unit because we are dividing centimeter squared by centimeter squared. And from here I can present the percent error, which is,
1.67.
and of course, no measurement unit. So the error in the area is a little bit more than 1.5% of the actual area. Good. So that was 34 on page 255, and you also selected 22 on 248. Twenty-two, 248. Yes, a particle moves along the curve y equals 2 sine pi x divided by 2. As the particle passes through the point 1/3, comma 1, its x-coordinate increases at a rate of dx over dt equals the square root of 10 centimeters per second. How fast is the distance from the particle to the origin changing at this instant? So if you graph any sine function, simple plane function, no shifts up or down. Doesn't have a shift. It has a horizontal, vertical stretching, and it has a horizontal stretching of the graph by pi over 2. But if you graph it a little, just for your out of curiosity, and you should because it's important, then the graph looks like this. Any point, if the particle moves along this curve, then the distance between the particle and the origin is this. I'm going to call it W. And of course, this is the x coordinate. And obviously, this is the y coordinate. And of course, I'm going to write that y squared equals x squared plus y squared. And the question is asking us to find how fast is the distance from the particle to the origin changing at this instant. So we are asked to find dw over dt when x is 1/3 and y is 1. So that is our question. I will differentiate both sides. And I will get 2w dw over dt equals 2x dx over dt, because when the particle moves, x and y and w all depend on time, they all change, and plus 2y dy over dt. Of course, I will simplify both sides by 2, and I will write that dw over dt is x dx over dt plus y dy over dt, everything divided by w. Now let's see if we have all the information we need. So right now I will say that x equals 1/3 and y equals 1. And if I don't have all the information, I will have to figure it out. But this is the expression we needed that will help us determine dw over dt. We have x, 1/3. We have y, which is 1. We have dx over dt, which is the square root of 10. I don't have a problem with determining w by taking the square root from both sides. So this is the square root of 1 over 9 plus 1. Square root of 1 over 9 plus 1 squared. So the only piece I'm missing is this one. But I'm given the function. Yes? Oh, from the Pythagorean Theorem, I know that this is 1/3 squared and this is 1 squared. So I take the square root from both sides to get w as 1 over 9 plus 1. Sure. So this is no brainer because I am given the function. But keep in mind that x is not a variable, but a function of time. So let's differentiate and find dy over dt, and everything else is done. So 6. So dy over dt equals 2 cosine pi x over 2 times pi over 2 times dx over dt. Let's see if this is clear. So y is 2 sine pi over 2 times x. So 2 cosine pi x over 2 times the inner function prime, which is pi over 2, times the derivative of x, dx over dt. So now I can put everything together. So then dw over dt equals 1/3 times the square root of 10 plus all this, which is 2 cosine, if x is 1/3, 1 over 3 times pi over 2 is pi over 6, times pi over 2, times again the square root of 10, and everything divided by the square root of 1 over 9 plus 1. So 1/3, the square root of 10, plus y, which is 1, and dy, it's all this, in which I replace x by 1/3, and this by the square root of 10. So I have the pi over 2, I have the square root of 10, and I replace x by 1/3. Pi over 2 times 1 over 3 is pi over 6. So now I will put all this in the graphing calculator at once. So parentheses for the top, don't forget that, please. So I have the square root of 10 divided by 3, and then plus. I should have put the square root of 10 outside and factor it, but that's okay. Plus 2 cosine of pi over 6. I didn't need that. I should have just written the square root of 3, but that's okay. Over 2. Okay. And then times pi over 2. So times pi times the square root of 2 and then divided by 10. The square root of 10 and then divided by 2. close the parenthesis, and then divide the whole thing by the square root, in parentheses, 1 divided by 9 plus 1. Yes. So I got 1.9424. What does this represent? So the rate of change of the distance with respect to time, but it has to be measurement unit in centimeters per second. Did you get the same thing? Yes? No, on your checklist when you turn it in.
I don't have my calculator.
I got the same thing.
You did?
Can you cancel the 2 in front of the cosine and the
Yes.
over 2?
Yes, of course.
That's what I
Put
did.
it down. Yeah. Okay. Just wanted to
Yes, of course.
double check.
Was my calculator in radians? It should be. No, it wasn't degrees. It wasn't degrees. I'm in radians. I have to do this again. No. You just hit me. No.
Thank goodness for that button.
Yeah.
Put the hole.
Careful.
I can't remember if I might have actually gotten that. I can't remember that.
Be careful. I didn't check. Normally, on the other computers, the software goes back to default. Here, it does not. Yeah, they trust us in this building, and all the other buildings they erase everything.
Yeah.
Be careful.
Wait, it doesn't erase everything when you log out.
No. No, not on this computer.
Is this the only building that
They
do that?
they trust us here. Any questions? The final number is less important. The work is more important. Okay. Is there anything else that you would like to go back to? Any type of problem in preparation for the test? Anything that you can think of?
I don't have a book there, I don't think anything, but maybe a logarithmic differentiation.
Okay, so let's choose a logarithmic differentiation. We can make one up. Do we want to look at a function raised to a function? Yes?
There were some problems in the checkbook that said to use, or in the checklist that in the book said to use logarithmic differentiation to find the derivative.
Right. So there is one type in which we cannot use any other method. And there is another type of problem in which we can use the quotient rule or the product rule, and there is no need for logarithmic differentiation. So you want one type then in which there is no escape, or not.
No,
The other one.
the other one where it was like, you could use a quotient, but the text said to use logarithmic.
Differentiation. Okay. We can make one up. For example, 30 on page 265. So y equals x squared plus 1 to the 4th power. Everything divided by 2x plus 1 to the 3rd. And times 3x minus 1 to the 5th. Okay, so let's say we want to apply a log, and we will not simplify it. Because if we need to apply log, in this particular situation, it is useful to apply log. It will be easier. It will be more difficult if we don't. So let's apply natural log to both sides. What do we get on the right? We get 4 Both of them are in the denominator. Both of them have to get negative in front.
Are you,
If two factors are in the denominator, both of them have to get minus in front. Otherwise, they will not come from the denominator.
and then 5 and then go up to it.
Yes. So do you understand what I just said? So if I have 5 factors at the top, all 5 have to have plus in front of the log. If I have 10 factors in the denominator, all have to have minus in front of the log. Anything that comes from the bottom of a fraction has to have minus in front of the log, because you will have to distribute a negative 1. So if the factors are in the denominator, they have to have minus in front. So now this is ready for differentiating. So 1 over y dy over dx equals what we get on the right-hand side. 4 over multiplied by,
2x.
perfect, minus 3 over multiplied by, very good, minus, surprise, surprise, I'm running out of room. I always do. Minus 5 over 3x minus 1 times 3. I will not do anything else, just rearrange it a little bit and multiply by y. So dy over dx will be x squared plus 1 to the 4th power over 2x plus 1 to the 3rd, 3x minus 1 to the 5th, times 8x over x squared plus 1 minus 6 over 2x plus 1 minus 15 over 3x minus 1. Everything okay?
Where did that factor come from?
This one?
Yeah.
It's y,
Oh.
because I have to multiply both sides by y.
Oh, I
So
see.
instead of writing y, I copied the function. Very good. Anything else that you can think of? I'm kind of asking you to redo the problems we did in class. Sometimes I do pick problems from the problems we did in class. So any questions? Please.
For the problems where you have to find the one we did about the disk and like the
Error.
spheres and
The error,
Mhm.
the measurement error.
you just
Okay.
need to know like the basic functions, like the volume of the
Yes, if there is something sophisticated, I will give you the formula.
Alright.
Yes.
But you said you don't even know like all the area formulas.
Well, we do need to know a little bit, right? Like the circle, the circumference, and the area, like the sphere, like the cone, the cylinder, a cube, pretty much. Anything else? Is there anything else you would like to practice? Anything else? Other questions? If not, I will start chapter 4. I can give you paper. I have plenty of paper.
I've got another section.
Good.
Figured that there'd be a lot of those classes.
Okay,
Because chemistry's in the middle though, so I got
good. So I also recommend you come in early on Tuesday if you'd like to start early, or if you have questions, that's fine too. It's not going to be anything super sophisticated. I'm sure you're going to do very well.
so.
Will you review everything that we covered in class? Okay. Do you think we can start chapter 4? Chapter 4. Okay. In chapter 4, So what did we study in chapter 2? Limits. We got used to determining limits, right? That's what we did in chapter 2. What do you do in chapter 3? Differentiation rules. What do you think we're going to do in chapter 4? Applications. Not yet. That's chapter 5. That's chapter 5. In chapter 4, we're going to apply differentiation in things. Okay? So applications of differentiation. One major application that we're going to start with is learning how to graph a function from scratch with no graphing calculator. It will not be banned. I'm not saying it's banned, the graphing calculator, but I'm just saying we will be able to determine everything about a function. And then we'll check with the calculator, but we will be able to, which we are not able to in pre-calculus or algebra. We cannot do that. So that's where derivatives come into play. Okay. So the first thing that I would like to look at is max-min. So that's 4.1, max-min. The first thing that I would like to discuss with you is what it's called critical number. Critical number or critical numbers. First of all, a critical number is an x value at which the function may have, not guaranteed, may have a max or a min. So a critical number is the x value or x values where f of x may have a max min. No guarantees till we do a lot of research behind it. May have. Okay, what type of critical numbers are there? Two types. Two types of critical numbers. Cn. One type of critical number comes from f prime of x equals 0. Why? It makes sense. So where the function has a term, the derivative is 0. So there must be a max or a min there. What is the second possibility, which also makes sense?
When it's undefined.
Perfect. When f prime of x is undefined, but something else has to be clarified here. Comma, but the function is defined. So this is very important. Not just that f prime is undefined, because if f prime is undefined but so is f, that's not a critical number. So the function must exist at that point, right? Continuous, of course, otherwise we don't talk about the derivative. So the derivative will be undefined, but the function is defined there. Okay. So also, I would like to caution you, because this is very important, how we determine max, min on a closed interval. And also we need to discuss how many types of max and min we have. So as you see, I am drawing a function on a closed interval. So let's say interval a comma b. It's a closed interval, and I'm graphing a function. Let's say this. This function f. In order to determine the max min on a closed interval, I have to analyze the function and also study the values of the function at the endpoints of the interval. And I'll explain how we analyze the function. Now, this point is definitely the minimum. It is the minimum point, and it will be called local. Also, we use interchangeably local or relative. So please get used to both. Some books use local, some use relative. Minimum. Why is this a local minimum? Because I can show the open interval. So I have to show the open interval that shows that all function values are bigger left and right than this one. So then this one is considered the smallest. So that is the local minimum. Is it also what we call absolute or global minimum for this function?
Yeah.
Yes, because there is no other smaller than it. Okay, now let's look at this end. Is this a local max? The answer is no. It cannot be a local max at the endpoint of the interval because the function does not exist on this side. I have to be able to show the open interval in which the function value is the minimum or the maximum and the other ones are higher or smaller, right? Depending on what it is. So this one is nothing. This does not mean anything. It's not a local max, it's not a local min, and obviously it's not the global max or absolute max or min. Now, what will this be? Can this be local max? No, because I cannot show the open interval. On the left-hand side, it doesn't exist. But it's definitely, for this function, what? The absolute, yes. Definitely. The endpoints of the interval can be absolute, but they cannot be relative or local. So these are the applications in the first section. So let's take a look and let's pick some problems. On page 281, so we're going to talk about finding max min on a closed interval. We're going to talk about first about critical numbers, and we can also attempt a couple of graphs. Okay. On page 281, find the critical numbers of the function, and I would like to start with 35. In 35 we have, I'm going to replace y by x so it's not confusing.
What page is this?
Page 281, sorry. We're given a function g of x is g of y, but I change it into g of x. As x minus 1 over x squared minus y. Nice. X squared minus x plus 1. Okay. We're asked to find the critical numbers. We're not asked to do anything else here, although I may ask you a couple more questions. Since I need to determine the critical numbers no matter what, if I need to graph the function or study the function, I have to find the critical numbers. What do I have to find first? Yes, but I have to find g prime, right? So the critical numbers come from two sources, but both sources study the derivative, the first derivative. So I have to find g prime first. So g prime, quotient rule, top function prime is, very good, times x squared minus x plus 1 minus the top function times, perfect. We all agree with that? Yes? I have to distribute. There is nothing I can factor out. I will always factor out if I can first instead of doing it by brute force, right? Distributing and combine like terms. But there is nothing I can factor out. So g prime of x is x squared minus x plus 1. Now I have to distribute, and remember there is a minus in front. So minus 2x squared, and this is minus x with minus in front, and this is minus 2x with minus in front, and this is 1 with minus in front. What follows next? Yes, so the positive x with the negative x and the negative 1 with the positive 1. So squared, very good, plus 2x divided by x squared minus x plus 1 squared. And now you know why it was so important in the previous chapter to factor out the negative leading coefficient and also factor the numerator. You'll see in a minute why. You can't get away from factoring. So first I realized that there is a negative leading coefficient, so I factor out negative 1, but also a common factor of x, right? So x times x with negative in front and x times negative 2 with negative in front. Finally, after all this work, I am finally ready to determine critical numbers. So remember, critical numbers come from two sources. A function doesn't have to have critical numbers at all, number one. Number two, it doesn't have to have critical numbers coming from both sources. But I have to check both possibilities. So first of all, g prime of x equals 0. When is the fraction 0? Very good. So then what are the two options here for the numerator to be 0?
0 and x equals 2.
That's it. Also, critical numbers come from g prime of x being undefined when g of x is defined. But even if this denominator could be 0, which cannot, right? So if you put negative b plus or minus b squared minus 4ac, you will have imaginary solutions. This is never 0. So, but even if this had zeros, since it's the same denominator, when this function is undefined, so is this. So let's say, don't change anything. Let's say I have here x plus 1, and I have here x plus 1 squared. This will be undefined at negative 1, but so it will this. So in this particular case, there are none coming from g prime being undefined. First of all, they're always defined, both of them, because x squared minus x plus 1 is never 0. But since the denominator is the same on g and on g prime, if g prime would be undefined, so would be g. So wouldn't make any difference.